All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So in this one, we're saying let's determine the force in members CD, CI, and HI of our truss shown. We're giving our support reactions. AX is 0 at our pin, AY is 2083 going up, FY is 1817 going up. I'm just giving those to help move us along. Hopefully we can find our support reaction without too much hassle at this point. So let's just jump into more to the truss material. But don't forget, we could, if we were doing this on like a homework problem, we probably would need to come in and find those support reactions first. Just make a free body diagram of the entire truss, find your support reactions. Steps we've gone through in previous material. But let's come in and tackle this. So let's mark off our, also we're told do this using method of sections twice, just to show that we can. So I'm looking for, let's take our members off. Member CD, that's this horizontal one up along the top. Member CI, just directly down below it. And member HI down here. So we want to ask, can I section through all of those in one go? I can't on this. I can cut up to 3 unknown members, but I have to get from one side of the truss all the way to the other side as I do that. If I came down vertically here, I cut 1, 2, 3. I'd be all the way out. HI is not in that. If I went down over here or slanted through that, I would include CI in there. There's no way for me to cut all 3 of these members in one slice, which is why we're doing 2 sections here. So we'll do one where I cut down the left half of this, and then one where I cut down the right half of this. And technically on these, I could circle either direction for any of them, but with this left slice, I'm going to circle around to the left. And with the right slice, I'm going to go down through the roller and to the right with that. Either way, though, it's really making 2 free body diagrams in here. We can tackle this. So let's start out and do that one on the left. So any unknown member should show up in here as an unknown force. So we'll redraw this, just putting in all of our uncut members as complete members. So if I start over here at A, I would have something similar to this. With one diagonal member right in the middle of that. Also at K, there's 1,000. There's a member that comes down here. But at K, there is a 1,500 pound force. 1,500 pounds going down. I know my width of this is 6 feet for each of these sections. So 6 feet. And the height is 5 plus 5. I don't need to know the midpoint on that. So I'm just going to label this 10 feet. I also need to get an AX and AY. AX is 0, so I'm just going to leave it off. But AY is 2083 going straight up. So going up 2083. And then I'm going to start getting my cut members in here. At J, as I leave J and go over to I cut member IJ. So I'll have one force going horizontal right here. FIJ, the force in member IJ. If I go up to C, I have member CI that I cut. It's going down and to the right because we always assume tension. So that'd be FCI. And we'll show it goes down and it would intercept with member FIJ at the very middle of our truss at point I. That's useful for us because that's going to be a great point to some moments about. We'd eliminate FCI and FIJ in here. Also notice I wasn't asked to find FIJ. It's not in here. In my problem statement, I cut through it though. It has to show up as an unknown in my free body diagram. We can't ignore it or we're going to get wrong answers out. But our last thing, I cut member CD up at the top. So going to the right, I have FCD. And FCD and FCI intercept at the top here at point C. So we'll label that as well. 3 unknowns, I have 3 equilibrium equations. I should be able to find all of them. So let's come in. I'm going to go up to the top here and start finding that. What do I need? Well, the one last thing I should label in here, there's this unknown angle, theta, that I'll need for FCI. Let's start there. Theta should be the inverse tangent of opposite over adjacent. The opposite to this angle would be the vertical. We drop down 10 feet, 10. Divide by adjacent, how far over, remember CI goes as it goes from C to I, 6 feet. The inverse tangent of 10/6 is 59.03 degrees. From there, I can start applying equilibrium equations. I have 3 unknowns in the x, 2 or just 1 in the y. I could sum force in the y and get FCI here. Or I could come in and do moments somewhere. I don't have to find Fij, so let's just not do it. Why don't I sum moments here at I to start out? That would eliminate Fij and FCI. I get FCD as my only unknown. I could find it. So with positive, going counterclockwise, summing my moments about point I. I'm going to have, again, I eliminate 2 of these in here. FCD will cause a negative rotation. So this is equal to negative FCD, and the distance is our vertical distance, 10. Negative 10 FCD. Our 2083 would cause a clockwise rotation, so I'll subtract it off as well. Minus 2083 force times distance would be my 6 plus 6 plus one more 6 foot distance, 6, 6, and another 6 is 18, times 18. I'll get the last one, the last line. My 1500 will cause a clockwise rotation about point I, so we'll add this in. Plus force, 1500, times my distance, 6 plus 6, 12. Is going to get me to 0. If I solve that for FCD, I'm going to get that the force in member CD is negative 1,950 pounds. And that was when I assumed that we were in tension up here, T. I now know, though, if I'm getting a negative, that's in compression. So let's show a compressive arrow. Any new free body diagram I set up, like when I do this one, I'll show it actually in compression, squeezing into my free body diagram, into the uncut members. That dashed arrow shows me what it's really doing. The solid one was my original assumption that I used in my equilibrium equation. My answer, I'll report it as a positive in compression. FCD is a positive. I drop the negative, 1950 pounds. And if I drop a negative, I change that T to a C, which would be my first answer in here. Always for trusses, give it as a positive and then say T or C, tension or compression. But with that known, I can now come in and say I have 2 unknowns left in here, FCI and Fij. Can I find both, or can I find what I was asked for, FCI, without needing to find Fij? And we can. I can just sum forces in the Y for that one. If I sum up my forces in the Y direction, I'm going to get that I have 2083 minus 1500, and I need to subtract off the Y component of FCI. So minus FCI times the sine of theta, 59.03. That's going to get us to 0, equals 0, which I can solve that. FCI is my only unknown in here. If I solve for FCI, I'll get that the force in member CI is 680 pounds. I get a positive number out from that, which means we're in tension. So T. Again, always saying T or C, reporting as a positive. Technically, I can now come in and I could sum moments at C, sum force in the X, and get Fij. I don't need to do that, though. I wasn't asked to find Fij. So let's not waste our time and do it. It's totally findable for us. If you were in my class and you found it, I wouldn't mark you down for it. You're just wasting your time. Instead, let's come in and do method of sections over here. So I need a new free body diagram for this one. So we'll just put it right next to this one. My uncut members, it's going to largely look like just a mirror image in here. But I have this free body diagram that I'm setting up. Something kind of like that. I know I need my roller in here. That was point F, 1817, going straight up. That was given to us. Fy is 1817. I have at G an 800-pound force, so I'll have to include it coming straight down, 800. 800. I have At H, I'm technically cutting a little bit after H, somewhere between H and I. That means I need to include that force here at H. I have coming down a 600-pound force. 600. My distances here are 6 feet for each of them. 6 feet, 6 feet. My height is 10 feet. And then I hit my cut members on this. I cut member HI. I did find this one. F, I didn't find this one. This is the last one that I need to find. So I'll assume tension and put in FHI. The force in member HI. Up here at D, I have 2 more members I cut. I cut member CD. I know that one though. 1950 in compression. If I'm in compression, when I originally found it, that I'm still in compression now, it's squeezing in on this member. So I'm going to show it with the correct direction in here. I know it's really in compression, so I'm showing it in compression. FCD is 1950. On this free body diagram, that means it's going directly to the right. On our original one, when we got those in compression, it means to the left. But either way, it's squeezing into our free body diagram. We're compressing here. And then our last one, I cut through member DI on this. So going down and to the left, I have FDI. Let's make that look like a D, not a P. FDI at an unknown angle, theta. Finally, we can label in here FDI and FHI. They're going to intercept down here at point I. So how do I want to find my last unknown, FHI? That is 6 feet away, by the way. We'll include that label. There's multiple ways I could try to do this. I need FHI. I could sum forces in the Y. It would get me FDI. Then I could sum forces in the X. FHI would be my only unknown force. That's totally valid for us. But probably the easy approach here would just be to say, if I go in some moments here about point D, I get rid of FDI in that. It passes through D. I can find my answer right away. So we'll do that with positive, going counterclockwise. Let's sum our moments up about point D. I'd eliminate FDI, FCD, and that 600-pound force also passes through D. So I could ignore it as well. But I'll get my 1817. That's going to cause a counterclockwise rotation. So we'll put it in as positive. We'll start there. 1817 times my distance, 6 plus 6 is 12. My 800 would cause a clockwise rotation. So minus my force, 800 times my distance, 6 feet. 800 times 6. And finally, my FHI would be the last thing I need to include in here. It would cause a clockwise rotation, so subtract it off. Minus, my distance for the moment is 10. So minus 10 FHI gets us to 0. I can solve that for FHI. It's the only unknown in here. FHI should work out to be a positive 1,700. I get a positive out from this, which means when I assume tension at the beginning, which is what we always want to come in and do, we are in tension. So pounds in tension, which would be our final answer for our problem. Hopefully this was a useful video for us. We can tackle trusses for this. I can almost guarantee you will see trusses on an exam at some point, maybe on your exam and your final. Figure out how to do these. But if this is useful for you, hit those like and subscribe buttons. Stick around. Let's get Q&A with JJ.